Hello everyone. Thanks for joining this third and final, or might not be final, but third programming session. I'm just going to wait like 1 or 2 more minutes, not very much longer, and then I'll get right into it. Okay, so if someone could just let me know if the audio is working fine in the chat, that'd be helpful, please. And then I will get started. Okay, cool, perfect. Thank you for that. Okay, so then I'm gonna hop right into it. So for this third session, what the plan um, is I'm going to go through a teleop practical. So walk through all the steps needed from um, figuring out what you need based on the hardware that your hardware team has created or your team has built, all the way to having a functional teleop that your robot has intelligent control for the driver control period. First I just want to talk about the kind of steps I want to talk through. So first we're going to talk about what is your config. This stands for your configuration. So we touched on it briefly. PJ touched on it briefly in last week's session, but I realized that we never actually covered what it is, what it does, and how to use it. So I want to cover that now. Then we're going to go into creating initializing hardware. We've covered that a bit, but I'm just going to go through it again because I want to go through the whole procedure in one go. And yeah, then we're going to move on to different kind of controls of different hardware components, show you how to do it, stuff like that. So it should be good. So yeah, let's go to the first slide. So the first slide, I want to talk about your configuration, right? So we talked about it last time, and you showed in the code, right? And let me just show you that quickly again. So in Android Studio here, when you have a motor and you want to initialize it, right? You say motor equals hardware map dot get DC motor dot class comma, and then you have these double quotation marks, right? So PJ talked about it last week about this is what you put, this is the name that you would have in your code to access your hardware on your actual hardware, right? So this is what I'm trying to show you, this name here. So you can say this is the motor name as an example, right? This motor name is what you put in your configuration. Now, what exactly is your configuration? So that's what I want to show here. Your configuration, sorry, let me get into the right slide. Your configuration is what tells your code over here, right? In those double quotation marks, that name is what you need to assign that name to a port on the control hub, right? So you would have seen this picture in the hardware training, but the control hub, you can see, right, is where you plug all your motors in, where you upload your code to, everything like that. We've talked about it in the past. But you can see this port, these ports over here, these are motor ports, right? Now, you can plug your motor into one of these ports here. You can see I've got the arrows going, right? So your motor is plugged into the port. But now your code needs to know how to access that port and it needs to know which port you're trying to control which then determines which motor you're controlling, right? So what the configuration does is it sits here in between the control hub and your code, and it assigns the controls you're controlling to a specific port on the control hub, right? So the configuration is you have a name for every port on the hub, and then using that name, you can access it in your code, right? So hopefully that makes sense. If it doesn't, put a question in the chat. But that should hopefully clear it up. I have a video now, if it works. It's been a bit buggy. Okay, here we go. But a short snippet showing what your configuration is, how you set it up, just to get you familiar with the UI and how it actually works. So I'm just going to play this short snippet quickly.
Okay guys, so let's get started. So I have a control hub and a battery here, and it's just plugged in to give it power so that our control hub is emitting a Wi-Fi, and then I have my phone right here. So if you guys don't know how to set this up, I'll link a video somewhere up top, and it'll bring you to a video on how to do this. So let's get started. So what you want to do is click these three dots up here. So click the three dots and then configure robot. So I'm gonna click new to make a new configuration, and if your thing or if control hub or expansion hub doesn't pop up, then click the scan button and it'll probably pop up. Make sure everything is powered and everything is connected properly. So now I'm gonna click control hub portal, control hub, and now here's a list of everything that you can possibly plug into your control hub. For this example, we're gonna test some motors. So I'm gonna go motors, and then for this example, we're using GoBuilda, this one, and I'm gonna type, let's just type it as motor, and then make sure you click done, and the most important thing is you click save. So I'm gonna name this as tutorial, click OK, and here we go. So now we have our configuration. So now if you have multiple configurations, make sure you activate the one you want. And now if we go back, if you look right here, so if you look at my mouse, it's gonna say the configuration right here. So as you can see, we're in the right configuration in tutorial. So if we click our teleop and autonomous, okay, so all that code is there, but we're not gonna worry about that.
Okay, so you can see there in this video, right? He's got his battery right here and his control hub, right? And his code has been uploaded to his control hub. In this case, he probably doesn't have any code because he isn't controlling anything right now. And you've got all your ports here, right? And then you've got your driver station here, which is what actually connects to your control hub and tells it which programs to run. So using this driver station, this is where you configure your robot. And you can see he went into the menu. I can click back just to show you the exact menu. You can see right here, right? He's in the control hub, and here are all the ports. So you got motor ports, you got servo ports, you got digital device ports, you got analog input device ports. Again, you won't be using all of these ports right now. The main thing are the servos and the motors, right? So these are actually where inside of these is where you put all of the names for each of the ports. And then using that back in Android Studio here, this is where you need to put the name you have in that configuration to access that specific port. So if, for instance, in the port or the configuration, we say port 0's name is slide motor, then we'll put here slide motor. And then this motor right here is anything you do to it. Say if you say motor dot set power, or that's set mode, set power to 1, right? That's going to set power to 1 on port 0 on the control hub. Yeah, so that's what the configuration is, what it does, what purpose it serves. So it's very important so that it actually your code knows what port to it's controlling. Okay, so I'm just going to delete all of that for now. Okay, and then if we go back to the slides, so that should give you an overview on the configuration, what it does, how you can do it. There are more tutorials online, but we don't have much more time to go into it. But hopefully that gives you a good understanding of what it does and how you use it.
Okay guys, so let's get started. So I have...
Okay, so now jumping into the actual the programming of the teleop, right? So I want to talk about this going through the process from starting here, like on the slide says, with the hardware, all the way through to having a working teleop so you can actually control the hardware. So like, what are the steps? What are the considerations you need to take? And then go through examples of like controlling a drivetrain, controlling the arm on this robot or the gripper, right? And having that in a teleop that you can then use. So that's what I'm going to walk through now. So the first step is you have to actually look at your hardware and consider what, if you're controlling motors or servos, what functions it needs, so you know kind of what you need to be programming. So let's look at a few of these steps. And the first thing we're going to start with for this, right, and I think you should start with for all FTC robots, is your drivetrain, right, your wheels. You need to be able to program it in such a way that your driver can drive forward and backwards and turn and stuff like that using input. So you can see right here, I've got an image of a gamepad or a controller, right? This is a Logitech controller. It's quite common in FTC. So this is a controller that plugs into your driver station and allows the drivers to input commands and stuff like that. So you can see here, the normal convention for controlling a robot in FTC would be to have this joystick over here, the right joystick. When you go forward or forwards, then the robot must go forwards. Obviously, when it goes backwards, the robot must drive backwards. And then for the left joystick over here, you're going to say if the driver pushes the left joystick to the right, the robot must turn to the right. And if they push the left joystick to the left, then the robot must turn left, right? So that's a normal convention for FTC. So that's the first consideration, right? It's like you have your robot, you have your two planes of motion or degrees of freedom. You have your forward and backwards movement, and then you have your turning movement. And this is the normal way you would program it for your drivers. If your driver or the person who's going to be driving a robot has a different preference, then there's no limitations to how you program it. But that's just the suggested method and what most teams use. So yeah. So then now that we actually have what we wanted to be doing, right, when it's going up and down, how do we actually do it? How do we turn the input of this joystick from the driver into motor power commands to move the drivetrain? So the first thing we need to consider, right, is with your drivetrain, and in this case it would be an omni-wheel drivetrain, right, which has been talked about in the hardware. With your two motors, what do you need to get them to do to make it to drive forwards or drive backwards or turn or whatever, right? So you can see in this image I've got some arrows here showing that if you make both of these motors turn forwards, then your drivetrain will go forwards. Obviously, that's the obvious one. And then backwards, it goes backwards. But then if we wanted to turn, we need to spin them in opposite directions. So this right one over here will go, well, depending on which side you want to call the front. I'm going to call this side the front. So this would be the right one. So when the right motor is set to forward and the left motor is set to back, the robot is going to turn to the left, right? You see I've got here, I'm saying the drivetrain will turn in the direction of the motor that is reversed. So if the right motor went backwards and the left motor went forwards, then it would turn to the right. So then now that we've got the concept, right, of saying, okay, here's the hardware we have an omni-wheel drivetrain. We want it to work in such a way that when the driver pushes the joystick forward, the right joystick forward, the robot goes forward, backwards, then the left joystick, if they push it to the right, it turns to the right. If they push it to the left, it turns to the left, right? So we have that, and we understand how the omni-wheel drivetrain works and how we need to turn it. So now, once we have that understanding, we can actually go into Android Studio and start programming it, right? So let me just go into Android Studio. So the first thing we have to do, right, like I mentioned at the start, we need to actually create our hardware and initialize it. So we're going to say DC motor left back. Let's call this left back. So we have the left drive motor. Okay, no. So we're going to actually call this left drive. And then we need the right drive motor. So we're going to say right drive. Okay, so now we have created the motors. Now we need to actually initialize them. So we're going to say equals hardware map, the default, like I showed earlier, DC motor dot class, comma, and then this is where your name from your config goes, right? So often it's named very similar. So we'll say this is left drive as well. and then I will just copy this one quickly, and call this one right drive, and then change the name here as well. So now we have created the motors for our drivetrain, and then we have initialized them or told them which port, motor port you're controlling, right, through the configuration. Now there's one other thing we have to do, and to do this I'm just going to show you on the slides again. So because these motors are pointing in opposite directions on the drivetrain, right, the default direction for forwards is clockwise, right? So if this is the back of the motor, this is the front, the shaft clockwise is this way, so that's forward, right? For the left motor, the default direction is forwards, which is what it's set to by default in the code. And so this one's default is forward, which is this way, but this one's default is also clockwise, which means its default direction is backwards on the drivetrain, right? Now this will cause problems because we want to say, you know, when you set a motor to power 1, it's going to go full speed forwards, and when you set it, or if it's by default, it'll go clockwise, right? But if you set the power to -1, it's going to go reverse. But the problem is here, if we say, okay, we want to drive the robot forward, and we're assuming that both motors need to go to 1, right? Because we're saying forward, that's positive. The one motor is going to go forwards, and the one is going to go back because that's their default direction. So what we have to do is we have to set the direction of the right motor to reverse, which will mean that when you set the drive motors, both of them to power 1, both of the motors will spin forwards. Then that just makes the programming easier. So what we'll do is we'll say right drive dot set direction to reverse. You know what? I just realized. I think you guys might not be able to see my prompts. So let me just fix that quickly. Okay, so I'm gonna just display my whole laptop screen now so you can see the prompts of everything. So when I'm programming and stuff. So what, like I was saying, now we're gonna set the right drive position direction to reverse, so that when both of them are set to power 1, they both go forwards, right? And then the last thing we want to do is we want to set the modes of the encoders on the wheels to drive without the encoder. So why do we need to do this exactly? Because we're controlling them in teleop, right, we're only going to be setting the power because we only want the direction they need to be driving based on what the driver is telling us, like I talked about, right? So we don't actually need the encoder or the thing that measures how much the wheel's been spinning because we're just setting the power. So it's actually just going to slow our code down and cause more issues. It's going to change how the power works a bit. So we're going to change it rather to run without encoders. So then I'm going to just do it for the right drive as well. So now we are done initializing our hardware, right? We've created the motors up here. We've told them what ports they're controlling. We've made sure they're spinning in the same direction. And then we are making sure that we are not using the encoders on them because we're just using the set power from the drivers, right? So now the next step is to actually, let me change this. Now the next step is to actually take the input from the gamepad and turn it into the robot's power, right? So how are we going to start with that is, let me just hide this, okay? So we're going to start with that by first what we need to do is we need to create a variable to store the position of the joystick. So the joystick, when it's pushed all the way up, is it's actually a bit strange. The joystick, when you push it all the way up forward, is actually -1, and when you push it down, it's +1. I'm not sure why that's the case. It's just the way it is. So we have to deal with it. So you need to store the position of the joystick as it currently is, right? So for that, you're going to use a variable. And how you use a variable up here by your motors, you're going to say double. So this is a type of data, a type of variable to store a certain type of data. So for a double, this allows you to store, let's just call it vertical, right? So vertical meaning the forwards and backwards movement of the drivetrain, right? So this is storing the joystick position, which tells us how fast the drivetrain needs to go forward or backwards. And this can be a double, right? A variable type double can be set to a number that has a decimal point, right? So if I set this, and this can also be set to a number without a decimal point, but if I made this an integer, right? I couldn't set it to a decimal point. It's going to get mad at me. And because the joystick has a range of 0 to 1 and anything in between that, we need it, or 0 to 1 and then 0 to -1, we need it to be able to store decimal points. So we're going to use a double. And this, we don't need to set it to anything. And then we also need one for turning. So now what we need to do is we actually need to set these things, right? In our loop here, which is the code that's going to run in a loop, looking to see if the drivers have inputted anything during while the program's running. It's going to check if the driver has inputted any commands. So what we need to do here is we need to update this variable to what the driver has currently inputted. So we're going to start with vertical, this equals, and now this is automatically there. So you can say gamepad 1, and this is the first gamepad that's plugged in, and you can have 2, but we're just going to stick with 1 for now. And then you say dot, and this gives you all the options for the buttons on the gamepad, all the joysticks. So we're going to say we're going to say right stick Y. So the vertical stick is Y. And this equals right stick Y. So vertical is going to be set to whatever the driver is inputting on right stick Y. So for example, if the driver pushes the joystick halfway up, it's going to get -0.5. So that poses a problem, as you would probably see, that we want the vertical to be 0.5, not -0.5 when the driver pushes the joystick up, because that should be forward, right? And the positive is forward for the drivetrain. So what we have to do is very simple, but it's just something to consider, is you just have to say the opposite. This is negative, right? It's the negative sign, the minus sign. But this just says that you should, this just inverts or reverses the value. So if it's -1, it's going to turn it into 1, which means if the driver pushes it all the way up, the joystick is going to say -1, but the program is going to, and vertical is going to get set to 1, right? Which is exactly what we want. And then for the turning one, we can just set it to not negative, and we'll say gamepad 1 dot left stick, right? We want it to be on the left stick, and we want it to be Y. We want it to be on the horizontal axis. And this one doesn't need to be reversed because right is positive, which is turning right, and that's normally positive in a program. And left would be negative, which is normally negative on the drivetrain. So now what we have to do is we've got the input from the driver, right? But to set the actual motor power, how exactly do we do this? We could say left drive dot set power, right, to vertical. But what would that achieve, right? We can set both of these to, we can say right drive, right drive dot set power to vertical as well, right? But this will work if your robot only goes forwards and backwards. It means that if vertical, or the driver inputs 1 on the joystick, the motor power is going to get set to 1 for both of them, which means the drivetrain will go forwards. And then if it gets set to negative, it'll go backwards. But if the driver wants to turn, right, it can't actually, nothing will happen because the turning isn't get inputted. So basically what we have to do is we have to combine these two values. So what exactly do we do, right? What we're going to say is we're going to say vertical for left drive, right? If turning is negative, we want it to be, if turning is negative, we want, let me go back to the slide so I can show you this. Try illustrate this. Okay, here we go. So if, right, over here, right? So if turning, which is the driver input over here, right? If turning is left or negative, we want the drivetrain to rotate to the left, right? Which means that the left one needs to be negative and the right one needs to be positive. So what we need to do then is, let me show this again, over here. So the left drive needs to be negative when the joystick is negative, which means we're just going to say plus turning, right? And then we're going to say over here is minus turning. So what exactly is this going to do, right? So this is going to say if turning is 0, right? If the driver doesn't want to turn, if the driver is not inputting any turning, then it'll just do drive forward and backwards, right? If the driver just pushes the forward one, it's going to get set to this plus 0 or minus 0. So it's not going to change anything, right? And the same thing happens for turning. If turning over here, actually no, it's not the same thing for turning, sorry. And then what happens is if the turning is happening, right? And we're saying, okay, turning is negative, then we're going to say, then it's going to be 0 plus, it's going to be 0 minus negative turning, right? And because turning is negative and you're subtracting turning, even though you're subtracting turning from number 0, it's actually going to turn it into a positive number. So then turning will actually be positive, and positive for right drive, and it will be negative for left drive, right? And the same thing happens the other way around if it's positive. I hope that makes sense. So that basically means that we can have an example here, right? Let me show you the slides again. If we go over here and we say, okay, the driver's inputted turning this way, they've given a positive 1 input to the turning, right? Then positive 1 normally, right, if you just set it to the drivetrain motors, it would set them both to forward and the drivetrain would just drive forward, right? But because of the way we've done this, it's going to convert on the left side, it's going to convert the positive value to a negative 1, and on the right side it's going to just keep it as a positive 1, and this is going to make the robot turn to the left. And then so basically that's it. That's all you need for controlling a omni-wheel drivetrain in Telia, for a driver to be able to input something and then allow the robot to turn or drive depending on what the driver wants the robot to do, right? So that's great. And the reason, okay, just one other thing I wanted to explain before we move on to the next thing is that the reason we need this, right? The reason we need to combine the two values rather than just going, okay, when the driver, we can do something like this, right? So look, we're saying, okay, when set the left drive and right drive powers to vertical or turning, and what you would have to do is you would say, if the vertical is not equal to 0, which means there's input from the driver, then you could set it to vertical, and if the turning one has input, then set it to whatever it is. But that would mean you can't turn and drive at the same time. Whereas with the method that we did, here, let me just go back to it. With this method, right, if the driver inputs 1 on the vertical, right, they want to go forward at full power, and they input 1 on the turning, right, they want to turn right, the robot, instead of going forwards or backwards or just turning on the spot, it's actually going to drive in an arc, right, because it's turning right and going forward at the same time. So it allows drivers to be much more maneuverable and fast on the field and be able to get around obstacles a lot better. Okay, so then moving on to the next type of subsystem, right? Maybe I'll just pause for a second. Did all of that make sense? Was there anything I missed, or something you'd like me to explain better? If not, I'll maybe wait like 15 seconds, 20 seconds, just if someone has a question. Otherwise, we'll move on to the next subsystem. Okay, it looks like no one's got a question currently, but if you do and you haven't managed to type it out yet, then just send it anyway, and I will pause whatever I'm talking about, and we can go through that. So now moving on to the next kind of subsystem, right? Now we have our drivetrain moving around, right? If we go back to this picture, we have our robot, we have the drive base, we can move around, right? Most important thing to start with, because if you can't move around, you can't do anything. So then moving on to like the next thing, right? And this is kind of the robot we're looking at here, right? This is the robot we have, this robot we're going to figure out how to program. We have the OmniWheel drivetrain programmed, right? And you can see here's the controller with the motors plugged in, everything like that, the battery over there. But now we need to actually control this arm, right? This is an arm over here. You would have probably seen in the mechanical sessions, they talked about how you're using a core hex motor to build an arm like this with gears. So now we need to talk about how, now that they've built the arm, how do we actually program it and get it to do something? So a normal, maybe I need to open something here to show this. Let me open this up. So let me just share this with you quickly. So you should be able to see this now. And please excuse my drawing, it's pretty bad on the computer. But if we say, right, we have our robot here, we have our wheels, right? And this is where the arm is, right? This is where the arm is. We've got a gripper on the end here, whatever. And our core X motor is right here with gears joining to it, right? So now the normal use of this arm would be, it would have a position over here, which the encoder would call 0, right? This is where the arm starts. So the encoder in this motor will say this arm, the position of this right here is 0. But normally you'd want something on this position 0, which is close to the ground. You grab stuff off the ground on the mats or whatever, and then you have a position to deposit it on whatever goal you need to. So like in center stage, you would have had to drop it on the backdrop. So then what you would normally want to do is have a way for the driver to be able to say, okay, no, I want the arm to be at position 0 now, or I want the arm to be at this position over here, which we can say is like 120 or whatever, right? Remember, this number is in ticks, so it's not a particularly useful number. It's different for every motor, but that just means you have to tune it for a motor. I'm going to show you how to do that. But that's just the idea, right? You're going to have two positions. You're going to have this position over here, which is the collect position, and this position over here, which is the delivery position, right? So now we need to figure out how we can get this motor over here to listen to us and do that, right? So that's what we're going to talk about now. So let's go back into Android Studio. Wait. There, okay. So we're gonna have the same, we're gonna do it in the same program, right? Because you want to be able to control your arm and your drive base in the same program. So first what we got to do is we got to create another motor, and we're gonna call it arm motor, right? And now we need to do the same thing over here. We need to initialize it. Dot get DC motor dot class, and then the name again, right? And this is the name in the configuration. So we can call this hex arm. So this is the core hex motor arm, right? And now that we've actually done this, right, we need to actually set it. We need to actually we need to do a few things with its encoder, because you can see here with the drivetrain, right, we've said run without encoder because we are only using the set power, right? We're not actually using the position of the motor. But for the core hex motor on the arm, like I showed you, we want a position 0 and then a delivery position. So a collect position and a delivery position. So we are actually using the encoder. Wait. Did the stream go down there for a second? Maybe I must just... I think there was an issue with the stream there for a bit. Okay.
when you I was working on the dishwasher there.
Is it?
The washing machine.
Frick, man.
Sorry.
Okay, let me check now. Sorry, there was an issue with the Wi-Fi. Hopefully it's back online. Oh, I don't know where I was cut off though. So let me just go back slightly, I guess. No, I'm not on currently. Okay, well, okay. Okay, I'm back now. Okay, cool. Sorry, I had to reload my chat then. I'm not sure what happened. Um, where was I at? I guess I'll just go back slightly. So basically what we're trying to do, right? I think you guys saw the thing I was doing in Microsoft Paint. I was drawing it. So basically what we're doing is when an encoder starts in a program, it doesn't remember where it was in the last program or where it has been moved if the program was, while the program was off, right? It could have been moved. Oh wait, wrong slide. Here. Okay, perfect. So it's working again. That's great. I'm sorry about that. So yeah, what we're trying to do, right, is the which is right stick X, sorry. Okay, I'm not exactly sure what you mean by right stick. I don't think I was talking about that at this point, but yeah, if you mean, oh yes, sorry. You mean left stick X, yeah, because it's got to be the horizontal. That is true. Right stick Y would be the vertical one, yeah. Yeah, you're right. So this was Y, it should be X. So yeah, thanks for pointing that out, spotting it. So yeah, with the, oh wait, I wasn't showing my Android Studio, but yeah, I fixed that. So with this arm, right? Like I was saying with the encoder doesn't remember if it has been moved. It can't track if it's been moved when the program's off. So that means whenever your program starts, the arm will always start in this down position, right, or wherever it rests naturally. And that means that at that natural point, you need to reset the encoder. You need to reset your coder to make sure it knows where it is at any point, right? Yes. So one should be Y, the other one should be X. Yes. You can see right here, this one was Y. It was supposed to be X. I didn't change that. So that's my bad. But good spotting. So then, yeah, back to the encoder. That's why over here, with the drive motors, we're setting to run without encoder because we're just using the set position. But for the arm, we want to have the position, so we're resetting the encoder to make sure 0 is at that rest point whenever we start the program. And we're saying run using encoder because we actually are running using the encoder, right? So now what we need to do is saying, if the driver presses a certain button, we want it to move to a position. So we need, if the driver presses this button, then we want it to move to delivery. And if the driver presses this button, we want to move it back to collect or whatever, right? So what we can do here is we can say if gamepad1 dot A, we can say A is where it should move to collect. We can say move to collect, and then if gamepad1 dot B, right, then we can say move to delivery, right? So now we need the actual code to tell the arm to move to that position. So because I was talking about how the encoder is in ticks, right? And for each motor, the amount it moves for a given amount of ticks is different, we need to actually, the best way of doing this, and because you have to tune it, the best way of doing this is to actually store the position for delivery and the position for collect in a variable like we are having for the drive code, right? So what we're going to do is we'll create another variable right here. And in this case, we're going to use an int because encoders can only take in whole numbers or integers. So they can't have any decimal point. So we want it to be an int because we only want it to be able to input whole numbers. So int will say delivery, right, equals, and then this is the number of ticks. So for a core hex motor, it's about 200 ticks for 180 degrees of movement. So in the slides here, you can see if the arm's position was here, right, like it currently is, this is collect, this would be 0. If we wanted to move up, so it's kind of pointing towards this heading right here, it's about, I would guess, I don't know, we can just say 90 degrees, right? Let's do 90 degrees around here. It just makes it simpler, right? So if we're doing 90 degrees, then let's say that the delivery position in this case is 100 ticks. And this would be slightly different for each robot, each motor, depending on how the hardware is built. And it's something you can tune, right? So a good place to start is just a lower number so you can see kind of how much it moves. So you can say delivery is 200, and then of course you would have int collect or the start position, which would be 0. So in theory you don't need to store this in a variable, but it just makes everything a lot cleaner, right? So if we go back down here, now we've got our positions for delivery and for collect in encoded ticks. For A, right, we wanted to move to collect. So what you're going to do is you're going to say arm motor dot set target position, right? And this allows you to, you can see, I don't know if you can see the pop. Oh, wait. I showed the wrong slides. I don't have the slides on. Okay, you can see here, right? So in the if statement, you're going to, in the if statement where if the driver presses A, what you're going to want to do is set the target position of the arm to the collect position, right? And you can see here this little pop-up window, it says int position. So you're inputting an int as a target position for the arm. So in this case, we're going to say collect, which is your variable right here. You can see here's the name. Wait, can you see the pop-up window? No, you can't. Let me show you the pop-up window. So you can see here, when you start inputting in, you can see here, it says collect, and it's the type int. So that's your variable up at the top. You can hit enter, it'll give you no errors, right? So now you're setting the target position of your arm to this variable up here, right? And in this case, it's the get when the driver presses A and you want it to move to that position or the collect position. So then what you're going to do is you're going to use a built-in function to actually that controls the motor power to get to that target position in that the motor is tracking, right? So you don't need to understand how this works at this point. Basically, it's very easy to use. You just say set mode. So it's the same idea as up here. You're saying set mode, but you're using one called run to position. So what this does, as the name suggests, is it takes the motor's current position and its target position, and it sets the motor power so that the arm will travel to that target position, and then once it's close, it'll slow it down and then stop it once it gets to that position, right? So that's what this run to position does. And then, yeah, that's all you actually have to do. It'll automatically set the power for you and drive the motor to that position, right? And now what you can do is you can just copy the same code, put it in here. And instead, right now, this one is here, move to delivery. It's when the driver presses the B button. You don't want it to move to collect. You want it to move to delivery, right? So now we've got when the driver presses the A button on the gamepad, we're going to drive the motor to the target position of collect, which is up here, right, which is 0. And then for this one, when the driver presses B, we're going to move the target, the arm position, to delivery, which is here, which in this case is 200 ticks, right? So now that we got that, right, we can, the driver can now, in our code, they can move the drivetrain like shown here, right? They can move it forward or backwards, turning forwards or backwards, or they can, so forwards and backwards or turning right to move the drive train forward, backwards, turn, or they can press A or B, A being the green one, B being the red one, and if they press A, it will take it to the collect position, the arm to the collect position, and if they press B, it'll move the arm to the delivery position or a higher angle, right? So this is the collect position, and then 90 degrees up would be the delivery position, right? So now that's kind of each step. So we can move the robot around. Now we can control the arm. But now the last thing to make the whole robot useful in the challenge is to actually control the gripper on the end of the arm. Allow the driver to be able to grab the game elements or anything, right? So I've got another slide here you can see. So now most of the time, and they would have talked about this in the hardware sessions, is you use a servo in your grippers, right? You can see here on the left, you've got two gears or cogs, and the one is driven by a servo, and they're connected together, and they move the grippers closer together when you turn them, right? So they go like this. And you can see also here you've got like some sort of gripper or trigger on the servo, as well as this is also showing kind of how a servo range works, right? It's its pulse range, and you can program that range. So now we're going to walk through exactly how you would turn the gripper of the servo, the gripper of on the end of that arm, right? This arm right here, you've got a servo you can see, and it's got a gripper on it. In this case, it's got a bar. You can see, I'll try to illustrate with my hands because you can't see it properly there. But you got that bar, that's the arm, and then you've got a gripper that closes like this against the bar, right? So what we need to do is we need to be able to control this gripper in such a way that the driver can press one button and it will open the gripper, and then another button that will close the gripper against the arm, right? And that will allow us to grab a game piece or whatever. So that's our aim now. So if we go into the code and we go here. So the first thing to do right now, we got our motors up here. We need to actually create a servo. There we go. And we're going to call it the gripper servo, right? And we're going to say equals hardware map. Again, it's exactly the same thing, except now because it's a servo, you'd say servo.class instead of motor.class. And this is also the name of the port that the servo is plugged into. So we can just call this gripper servo or something, right? Doesn't really matter as long as it matches what's in your configuration. And then that would be basically all. In the mechanical session, they talked about actually how you change the servo's range, right? So like in this, where's the slides? Here we go. In the slides here, right, this middle one, you can see the servo's range, right? And you can actually change that range using something called a servo programmer. And they would have talked about that in the mechanical session a bit. But that basically allows you to program this. You can see this green range. That's normally the physical range that a servo can actually move without it actually being stopped mechanically inside the servo. But you can actually make that range smaller or smallest from one side specifically or something like that if you want to, using the servo programmer. And that's something I would talk about in mechanical. But we don't really need to know that at this point. All we need to assume is that the thing's been programmed to a specific, and it doesn't even need to be programmed. All it can be is just a servo on the robot, and these rev servos, which is the ones that are most generally used and will be in the starter kit, they have a range of 270 degrees, right? And so we can assume, if this is the arm right here, that the gripper needs to close to say 0 degrees, if that's the start of its range, and it needs to open to maybe like 90 degrees, just so that it has a nice wide grip, right? So that's our aim. So that's all we need to know at this point. And you can possibly play around with programming it a bit more later, at a later stage. But that's all we need to do up here, right? We tell it which port it's controlling. And then down here, we want to give the drivers buttons like we have for the arm to be able to tell it to open or close. Oh, wait, I didn't change the slides, did I? Okay, so basically what we want to do up here, we've already finished telling it which port it needs to be, right? We've created the servo. And now what we want to do is we want to create another thing that says when the driver presses a certain button, we want it to either open or close. And we want it to do either one, right? So first we're going to say if we can say gamepad1 dot A and B have already been used for the arm, right? So we'll say Y. And then we'll say if gamepad1 dot and Y, X, and 1. So yeah, we have X left, sorry. So now we have this, right? We can have Y as open the gripper, and then we can have X as close the gripper. Right? So now inside of this, we want to say actually what it needs to be doing when the driver presses this button to actually close it. So we'll say when the Y, we want it to open. So like I mentioned, when the gripper closes, it needs to be at 0 degrees, and when it opens, it needs to be at 90 degrees. Now the interesting thing about this is in the actual code, you don't actually input the position of the servo in degrees. So you can't input, say, okay, it's got a 270 degree range, like I was saying, right? You can't say, okay, go to 90 degrees and then go to 0. That would be useful, right? But it's not the way that the code works. So what the servo range basically works is it goes from 1 to 0. So if you have a 270 degree range, right, and you want to go halfway in the middle of that range, which would be 135 degrees, you would need to set the servo to position of 0.5, right? So that's basically how that works, and that range will change. So if you change that range with the servo programmer, instead of being 270, it's going to be 90. The middle of that range is still going to be 0.5. So if you go to 45 with the 90 degree range, it's also 0.5. So what we're going to do in here, we'll just say, it's a lot simpler. It's simpler than the motor. It's only one line. We'll say dot set position. And the reason it's one line is because we don't need this controller for a servo. The controller is actually built into the servo that drives it to a certain position. So we'll say set position. We want this to open the gripper, right? Which is going to be 90 degrees, which is a third of the range. So we'll say 0.33, right? So we want it to open. I mean, in this case, 90 degrees is probably quite big. So we'll just say 0.3 to make it slightly less. And then to close the gripper, we want to close it to 0, right? So this means that if Y is pressed, it's going to set the gripper to 0.3 or open it. And if X is pressed, it's going to set it to 0 and close it, right? So now you can see how this is done is, let me show you the slides again. We've gone from having just this robot over here, right, with all these different subsystems on it, to having a teleop that can intelligently control all these or take input from the driver and be able to actually integrate and be able to get all these subsystems to work together, right? So you can have the drivetrain, the driver can go drive somewhere, put the arm down to collect, grab something, and then drive back to wherever it needs to take the object and go lift it up to delivery and then drop it, right? So you can see how we've gone from the hardware of the robot to actually converting it to a place in the code where the driver can input commands and actually the robot will listen to those commands and respond as you would want it to. So you can see the servo. So now that is the end of today's presentation or session. It's been quite a long one. It's actually probably been the longest one we've run overall in Ignite. So hopefully it was insightful though. So this week's assignment is basically going to be creating a similar thing, right? I don't want you to go and just copy what I've done in the session. What I'd like you to do is to just take the time to think about it from a similar perspective. Again, I'm not saying don't watch the video back, but I think it's very helpful if you can think through it, go, okay, now I've got this drivetrain, think through the concepts, make sure you understand it, and then implement it in the code for you, right? Yeah, so I'm saying using the program you created last week, convert it into a teleop with some driver controls. So think about, okay, now I've got an omni-wheel drivetrain, this is what I need to do. I need to add more motors, I need to initialize it, I need to put the names in for the configuration that I would have, so like left drive or right drive, and then this is what I need to do to get the driver input, and this is how I turn it into commands for the hardware to follow, right? So yeah, I hope that makes sense. I will be posting another link to a form where you can submit a screenshot of that code once you finish it. That'll be the final assignment for the software. We haven't covered auto in this. We might do another session or a recording maybe of running through an auto similar to what we've done today. So yeah, let us know in the Discord as well if that would be helpful, if you'd find that helpful. So yeah, that would be it for today then. If anyone has questions or anything, I'll be on for a few more minutes. But otherwise, yeah, thanks for joining, and I will send out the assignment form in in the near future. Okay, it looks like there are no questions. I see. Oh, what about error handling? Um, in this basic code, most of the time there's no real errors to handle, and if there are errors, they'll be with actually communicating with the hardware. Do you have specific thoughts on what errors could occur? Um, but for the most part, this is a very basic program to start with. So there's not much error handling to do in this code. Um, yeah, so if you're talking about like hardware error handling, like when the motor's not plugged in and you try to set power to it, that'll be handled in the FTC SDK, so you don't have to worry about that too much. Basically, if you set the power of a motor, it's not going to crash anything. If you set the power of a motor and there's no motor plugged in, it's not going to crash anything. You obviously just won't have any power on the motor because it's not plugged in. You will have an error, however, if you will have a null pointer exception or null object reference if you have the wrong name. Let me quickly open here. If you have the wrong name here, if you have a name here for your motor or your servo that doesn't match a name for a motor or servo in your configuration, then you'll get an error thrown and your program won't be able to start. However, nothing's gonna break. You're not gonna have any big issues. Your program just won't start. Then you're gonna have to come back and fix the issue. So it's not like you have to worry about, oh, you need to say only if this returns like a positive message, like it worked, then continue, or only send it if you can find something, because it's not gonna break anything. Your code just won't initialize, which means, and it will tell you exactly where the error is, and then you can go and figure out what the issue is like that. So yeah, it's the SDK is good at giving you stack traces to find errors and stuff like that. I hope that answers your question. Okay, well then, if we have no more questions coming through now, If you do have more questions, then chuck them in the Discord. There's a Q&A section, so you can do that. But otherwise, yeah, thanks for joining, guys. I hope it was helpful. And yeah,